I was at a meeting in, I think it was Ameren, and I sat in a room like this, and it was segregated in such a fashion where there was the, I'll call them the old timers or the old seasoned guys that have been around for a while, and there was a group of, the next generation coming off the bench. And it was interesting listening to them talk, because they say, oh yeah, I can just go over there and smack with a hammer, put some duct tape on or whatever, get it to work. And these other guys over here on this side of the room are saying, I'm not getting near the equipment. I know what the arc flash issues are. I know the dangers. These guys had gotten so comfortable with the equipment that they had no fear. And these guys over here have been trained because they're coming off the bench, and they had a lot of new training under their belt, and they were very cautious. But what we're faced with today is the issues that are associated with that old gear. You've got degradation of the insulation, you've got old breakers, old technology, EM relays, electrical mechanical relays. You're dealing with a lot of issues that are basically you've inherited from the past, asbestos issues. So now you're dealing with environmental issues, and that ripples into safety concerns too. Operator safety is obviously an issue. Many of the customers have now had arc flash studies done, and then they now know their incident energy levels. They want to understand, okay, now that I know that, what do I do to make that better? Forced outages. If you're whether you're an industrial or utility customer, and what does an outage cost you? Whether it's an hour or a day, you can quickly roll up to hundreds of thousands, if not millions of dollars, just from an outage because of a reliability issue. Maintenance support. We mentioned a second ago about the attrition in the workforce. Where's the talent coming from? There's not a long line of people coming off, out of college and so on, saying, I want to learn how to work on breakers and switchgear. That's just not an industry draw, if you will. And from the service organization, I can attest to that because we struggle today just trying to find good talent that knows how to do this. Here's some of the challenges that we'll talk about, that you're probably facing if you've got aged infrastructure. What are the most cost-effective approaches or options for improving that gear? Each one of these scenarios will be a different case, if you will, based on customers. Some customers will have a timeline of saying, I need to keep this plant up and running for another 5 years. I know it's going to be decommissioned. Some people, we've been faced with some of the situations at some of the nuke plants where they've relicensed the plant. They want to extend the life another 20 or 30 years. They're looking at what are their options. We look down through these different options, and how do we approach these things in a systematic way where it makes sense. And what I'm doing is I'm laying the foundation for you to understand how this tool works, because there's a lot of key inputs that we're going to put in, and it takes about 5 to 7 minutes to put these inputs into this Access database. And as I mentioned before, this thing started off with, I had a customer, it was National Grid. We were selling them some rolling replacement breakers. And they said, well, how do I know that this is my most cost-effective approach? So we went through the exercise of basically, doing a life, a cost over a period of time, let's say 20 years out, of them keeping the old breakers versus them replacing the breakers, and then showing them the return on the investment based on their decisions. So this is basically what that tool is going to do. And in each scenario, as I indicated, it's going to be different from case to case. There's other things that need to be concerned with. After you've had your arc flash studies done, you say, okay, I know my incident energy levels are high. Basically, I've seen some situations where the incident energy levels are so high that you wouldn't be allowed in the room with the equipment. They've actually had to barrier it off. What happens if you do nothing? Is there any liability exposure at the end of the day? Let's say that we have an operator that gets hurt. Ends up in court. The guy's suing the company because he felt like he got injured because the company didn't do the right thing to ensure his safety. He's probably got a good case, but in many times there are situations where you can short circuit some of these things. As far as addressing safety issues. Even if you've got old gear that's 35 or 40 years old, you're not going to make it arc resistant. You'll never get there with that. But there's things that you can do to protect your employees, reduce the PPE requirement, reduce the incident energy level. We do that through arc flash mitigation relays, remote racking, new technology breakers. There's less exposure to the front of the gear and so on. So there are methods for improving that situation. And then budgets. Many times, customers are faced with, do I just do a wholesale replacement or do I upgrade it? Do I continue to maintain it? So there's options to look at. So what we put together is a tool that will basically take you through these steps of evaluation. And if anybody in here has ever used TurboTax, it's kind of like this. Say, well, if I donated $500 more to Goodwill, does that change my picture any? It kind of gives you an option where you can plug and play some numbers and say, well, let me take that off the cafeteria and let me add this in and so on. And we'll get to that in a second. So anyways, what we're going to do is we're going to determine the objectives. In each case, as I indicated, the primary driver may be safety. It may be life extensions. It may be reliability issues. Whatever. In each case, it's going to vary from customer to customer. We need to understand the budget and the time constraints. Do we have a long period of time where we can phase this in, or is it just something that we just need to get done immediately because somebody got hurt? We recently had an incident at a plant in South Carolina, and I should have thrown these pictures up. In fact, I might, if I got a minute, I'll throw them up at the end of the presentation. An operator was in front of the gear. You can still see the open door and the racking handle, and he was in a PP level 3, level 4 suit. The helmet is melted, the arm is gone, the fingers on the gloves are gone. We laid it out on the ground and took a picture of it. It just speaks volumes. The guy survived. He got some burns, a couple of broken bones and stuff. But when you see this protective equipment he was wearing, you'd think he got killed. Understand what your current O&M costs are today. You may find out that as you've tried to maintain this old gear that, some of these parts are getting pretty expensive, hard to find. You can't find people that know how to work on them. It just starts ramping up. It's just like trying to keep an old car on the road. Establish the current health and immediate needs. We have methodologies, we have tools to do this. We can go in and do an assessment on the gear. Basically, calibrate what is the condition of the gear, what are the priorities, what do you need to address first, second, and third. So help you prioritize the things so that you can sort of time phase that spending. We're going to get into entering the customer inputs into the cost models here in a few minutes, and then evaluate the results and then make the decision. And I'll be asking for somebody in the crowd to say, I'll volunteer to give you some inputs. And basically it'll be very simple. It'll just be, how many frames of gear is it? How long do you want to extend the life? What's your full burden rate? What's your PMs? What's your refurb cycles? Just do, simple questions like that. We have service technicians go in, take a look at the gear, take a look at every piece of equipment, whether it's a motor control bucket or a circuit breaker or what have you. Go through and do an analysis of the breaker, and then basically give a conditions report across several variables. These variables are inputted into a program, and with some algorithm programming, it basically calculates what the risk factor is on this for failure. This is an output of one of the assessments that we did at one of our customers. And the thing is that when we took the outage to do this assessment, and I'll explain these different bars here, is that we have a before and an after. And what we were able to do is, as we did the assessment, we were able to take it from a critical state here as it was found, do a little bit of PM and move it into one of the other buckets. So we were actually able to do some PM and change the state of some of these critical pieces of equipment. This is the cost-benefit analysis output. And I've just got a sample here of one of the graphs that this will put out. And basically, what we're looking at is it compares your options. One of them is to just basically maintain the gear, do the breaker refurbishments. And let me back up 1 second here. One of the things that you need to understand is that there's a cafeteria selection of the upgrades. For example, if I tell you that, if you told me, you said, I want remote racking done on my switchgear, it's going to take remote racking and apply it to the existing breaker refurbishment option, to the breaker retrofit option, and to the switchgear changeout. So you're comparing apples to apples. So if you've got one upgrade, you've got that upgrade across all of them. Where that would not apply, though, is on a relay upgrade. One of the relay options is when we go into a 70-year-old piece of gear, take out the EM relays, put the microprocessor base in. We basically engineer a door, mount the relays, pigtail it, wire it in. You know, if you got new switchgear, you're going to have those new relays. So, you know, there's some disclaimers there, if you know, just so you know how we do that. I'm going to make it interactive as possible, so it's just not a boring presentation of me up here telling you what you need to hear. So I'm going to ask somebody in the crowd, so you know, if somebody would volunteer, I'd appreciate that, and we'll just take your inputs and we'll play out the scenario. You know, if we got time, we could do a couple of scenarios if you'd like. We'll address all the major components of the gear. We talk about primarily the breakers, the relaying, and such. But there are some things that we don't bother with because we don't see a high demand for them. PTs and CTs, we rarely see failure on. Cable landings, we don't look at that kind of stuff. You know, and it depends on environmental impacts. You know, whether we even go down that path or not. We need to understand the factors in maintenance. You know, are you looking at these breakers once a year? How many hours does it take? Are you spending 1 hour per breaker per year? Or are you spending 1 hour every 10 years to look at the breaker? Are you doing refurbishments? Are you doing the refurbishment cycles based on, you know, the vendor's recommendations? And then we'll calculate some of the cycle times. I don't spend a lot of time on that, but I only bring it up from the standpoint that if you're going to do a demolition and installation and commissioning of a new piece of switchgear in an existing application, you're going to have some downtime. Okay, you're just going to shut it down. When you look at some of the retrofit applications and the upgrades that we can do, some of these things can be done in short duration outages and time phased over a period of time. So, you know, that's going to change, you know, depending on the selections again. These are some of the decision factors. And I mentioned it before. These are them again. You know, these are the options. You know, we're either looking for life extensions, reduce the maintenance costs, safety upgrades. We've developed some arc flash concerns because of the arc flash studies. The in-house talent has left the building at the last retirement party. Budgets are you know, getting squeezed. You're saying, man, I'm making, you know, it's just like making a car payment on a 20-year-old car. You say, I might as well just go buy a new car at this point. So, you know, you got some budget impacts. Long-term cost of all the decisions. I'll show you a cumulative cost over time comparison. Not only will I show you you know, that little graph that popped up a little bit ago, but I'll show you, you know, basically the time and the cost over that time period. I think I use a 20 or 30 year horizon on, but it's in this presentation, so it won't come out of this output. Long-term cost of all these decisions, you'll see that. The downtime, we talked about the cycle time a second ago, outage duration, engineering impacts. There will be some of that, you know, as we talk about retrofitting new gear. There'll be some engineering because, you know, if you've got some, you know, 20, 30-year-old gear, you're going to want to do some engineering to say, I want this type of upgrade, and it's dependent on, you know, whether you do it in-house or outsource it. And then parts. In many cases, you know, whether we're doing it on low voltage or medium voltage, and this tool can be used for either one. In many cases, you can standardize on a breaker element. Whether you know you're on the low voltage situation, we have an opportunity to say, well, I've got to line up a Eaton Cutler hammer over here. I got to line up a square D, and I got to line up of ABB. We're able to do a cradle and cradle install on those low voltage breakers, and now you've got a standardized element across all three vendors. Now you've reduced the parts inventory, your training, and your procedures down to one standard format. When we look at the breaker refurbishment advantages, on the factory advantages, we obviously have the factory expertise. When we look at the ITE lineage breakers, we actually have a shop that just tears them down completely to every nut and bolt, as you can see in that picture there. We clean them, re-grease them, repaint them, replate them, everything. And actually, this facility here is actually capable of doing 1E or nuclear type work. So that's the level of competence that we have at that facility. If you run it through the factory, we obviously have the latest drawings, so if there's any upgrades, that will be incorporated in there also. And then the warranty that we give is as a new breaker. It comes out of there, it's got a 12, 18 month warranty, 12 months from the time of an install or 18 months from the time of delivery. So, basically you got a pretty good, situation here on the factory refurbishment. On the in-house advantage, for those that have in-house breaker facilities that you do your own refurbishments, what you have is, you've got the ability to be a little more flexible on the scheduling. When you got an outage, or where you got open capacity in your breaker shops. It'll obviously be a reduced cost. There's no shipping involved. You can probably do it cheaper internally than you could send it out. And, it gives an opportunity to develop the expertise internally. When we look at replacement breakers, and now I use the medium voltage primarily in this presentation. I mentioned the low voltage, but I'll focus on medium. If you haven't seen it, I welcome you to come down to the show floor and take a look at it. We've got magnetic actuated breakers. We've got them across almost all our product lines now, from the outdoor distribution breaker to the reclosures to our rolling replacements to our standard indoor switchgear. And we use that same element on all the medium voltage breakers. And what you see here is a GE Magnablast breaker, I believe, and we basically just bolt all the stuff on it so that it adapts and fits into the existing GE cell. The AMVAC gives you the latest technology. There's primarily 7 moving parts on the AMVAC breaker. It's just basically the jack shafts and the rods in there. The rest of it is basically the magnetic actuator, and there's a control board on there. So there's very few replacement parts. The maintenance on these things is, they meet ANSI standard 2 or 3 times the requirement. Reduced training, so since there's no real maintenance to do to them per se, there's not a lot of training to do. Longer life cycle, longer warranty period, and modular units are simple to repair. So the bottles come right off as a modular unit. The control boards come out, they just slip right out, and so on. And then we get into the switchgear. Again, the disclaimer is that anything we do on the retrofit or the upgrade of the equipment, you'll never get to an arc-resistant situation. There are some exceptions. We can basically get you to 25 kA Type 1 arc-resistant gear on a 5HK lineup. That's the exception. But the rest of the gear that you have out there, probably there isn't any engineered options to this day. But, here's the advantages of taking other decisions, is that, the majority of the people would probably say, well, for 10 or 15% more, I'll go with the arc-resistant gear. It just kind of makes sense. It's you got a wholesale change out, so you got an opportunity. You got a fresh start. You've wiped the slate and you've started over. So you don't have any of the old wiring, the old relays, the old breakers, and you're moving on. So then you've got the arc-resistant protection, which you didn't have before, the latest technology as far as the breakers, the relays, and so on. All your engineering upgrades have been incorporated. Your reduced maintenance is there, and you've updated your training, and you meet the latest standards. The only difference here on the conventional side, the non-arc resistant gear, is you don't have the arc resistant protection, but basically you've pulled over all those other things. Why don't you go ahead and give me your details? Okay, we've got a lineup of what kind of gear? 5, 15 kV? 15 kV. How many frames is it?
What do you mean by frames?
Vertical sections. 14. How many breakers you have in it? 10. What would you like to do with it? Would you like to extend the life?
Sure.
How far out?
That's good. 30.
30? Okay. What is your current preventive maintenance cycle? How often do you look at these breakers? You go out there and dust them off once a year, once every 5 years?
Once a year for mine.
Okay. And how many hours do you think you spend on that?
For each breaker, probably 6 hours.
You think that? Okay. Now, on the new breakers, I kind of put in a default number. This is my assumption. So anything that you see news here is my assumption. I say on a new breaker, somebody's going to go out there, pull it out of the cubicle, dust it off, and if you don't agree with my assumptions, I'll change it too. So I put 2 in there because it's a low maintenance, high reliability breaker. If anybody wants to dispute it, I'd be more than glad to change it. Refurbishment. How often do you refurb your breakers? Yeah, full refurbishment. Never? Okay, I'm not allowed to put 0 in here because there's a lot of math in here. So I'll put in like, how old is the gear? 30 years old? Let me just say 30 then instead of 0 because, you try to divide something in an Excel spreadsheet by 0, you get a default, okay? It'll actually give me a flag and say I can't put 0 in there. Okay, the cycle on the new breaker, the vendor recommends once every 15 years. Okay, labor on the old breaker, if you did a refurbishment, would typically be about 50 or 60 hours. So, okay, so you wouldn't even do it in-house, you would send it out. Okay, I'm just going to put an hour in there, just for the sake that it won't give me a flag. Okay, labor on the new breaker, since it's low maintenance, I put in 20. Okay, now we're going to go to the other areas here. Okay, this is the parts kits for the breakers. What is your current labor rate, your burdened rate at where you're at? 50? And parts kits for most of the old breakers, I know what they are because we sell parts, and the kits run about $1,200. Parts kit for a new breaker, since there's less moving parts, we got it $250. I'm not going to mess around with the cycle time stuff in the interest of time. Okay, I'm just going to, I have that in there, just for the sake of playing with the graphs, but, for this exercise, I'm not going to mess with that. So we hit enter the inputs. So we've got, and these again are your inputs here, this is for the exercise of saying, if I'm going to replace the gear, what is it going to cost me on a vertical frame to do this as far as the installation and commissioning? We look at taking the frame, landing it, hooking up the cables, doing the continuity testing, doing the functional testing and turning the key and, getting it hot. So, I think the last guy gave me $6,500 a frame. So, it could be anywhere from $5 to whatever you want to tell me. So, okay. And these numbers right here that you see are default numbers. Are $45,000 a frame for arc resistant and $40,000 for non-arc resistant. I think that's a little on the low side, but we'll just leave it there. Engineering, when it gets into you're going to replace the gear, so now you're going to go through some engineering costs to be able to say, here's what I got, here's what I want. What do you think that would run you on a vertical section? Okay, we'll put 2,000. And then the demolition of, taking the gear out and hauling it away and disposing of it on a per frame basis. Because it varies from customer to customer. Because the reason is that sometimes it's in an enclosed building, up on a mezzanine. You got to get a crane, remove a roof from a building, whatever. So sometimes these costs can be, catastrophic. They can just go out the roof. But sometimes they're relatively cheap. Okay, now all the rest of these that I'm going down here, from the REA, arc flash mitigation, all the way down through, are options. And you can say, yes, I want the REA relay. If you don't, I can put a 0 in there. I can do zeros in here because it just basically deletes it from the option list. The REA is the arc flash mitigation relay that can be added into your equipment. Do you want that in there? Okay. And you don't want any remote racking. Okay, so that basically runs about $3,000 a frame. I know that for a fact because I quote it. And you don't want remote racking. Okay. And replacement breaker, this is a pretty good swag on market level. I have to plug that number in. It doesn't say that you're going to buy it, but it compares it to the other options of refurbishment versus replace versus, okay? And then the factory refurbishment, I know what that is, and that's another comparable point. And then we've got relay upgrades. Very typically when we quote relay upgrades, like I described before, it's basically removing the door, engineering a new door, mounting a new microprocessor-based, pigtailing it over and tying it back in and commissioning it. I mean, that runs about $9,000 a frame. And you want to leave that one in?
Yeah.
Okay, now the rest of these things, IR parts, you want that in or out?
No, I guess not.
Okay. And then we have the roll and replacement installation and commissioning. Since I got to compare these, this is what we charge to do it. Shipping each breaker costs about $250 each, whether it's back and forth on the refurbishment for factory or for the roll and replacements. And then the shipping of the switchgear is about $500 for each frame. So basically, we have completed the customer inputs at this point, and we go to the results page, and let's hope it all works out. Get results. Okay, so now I've got the results. So now what I've got here is this was your inputs. Okay. So what we have is, essentially we've taken all your inputs based on your number of frames, and if you were to do that with SafeGear today, that thing would run you about $850,000. Okay, with all the installation and commissioning and so on. When we look at these other ones, of course, they're cheaper options, but at the end of the day, what do you got? You got the old gear, you got the old breakers. We put the new relays in, we put the arc flash mitigation, but that's all we did here. And then when you look here you've got it's like putting a new engine in a car. For $320,000, you've got the arc flash mitigation, you got brand new relays, you've got brand new breakers, and you basically extended the life. This is what I was talking about before when I said that we can show you over the course of time what it would cost you. And when you look at these, there's your options for your switchgear. Now these aren't your numbers; these are something that I had cut and pasted in there earlier. But for the sake of the exercise, what we've got here is you look at the arc-resistant gear. Relatively low maintenance, low cost on refurbishment. You look at the old gear. The yellow line is the factory refurbishment, and you see the big blips there every 10 years to do the refurbishment, and then so on down the line. So this kind of gives you a forecast of how your cash is going to flow out over the 30-year span. So this is basically the conclusion. Basically the replacement gear, it provides all the benefits that we know that we went through before as far as the advantages. It reduces the arc flash, provides the arc flash protection, renews the total system, improves technology, refreshes the training program, reduces O&M, and so on. And when we get into the refurbishments, talked a little bit about that a second ago. Basically what you got is you've just got reconditioned gear with no new technology and no real reliability improvements. You're just maintaining it, keeping it going. And then when we get into the replacement breakers and the other upgrades, we've actually improved the reliability, we've improved the safety, we've updated the training and the parts and reduced parts inventory, and the overall cost influenced by some of the upgrades. We talked about the selection on the cafeteria stuff. And then I mentioned before, some of the things like CPTs and PTs, you may have to look at it depending on your systems and environmental impacts. But if I was making the decision, I'd take a look at the replacement breaker options with the safety. Because it's almost a third of the price, and you've basically not taken a downtime, and you've actually made the improvements. I appreciate your time.